At first, it was just a technical debate about soil and its workability. Then suddenly, trucks began dumping millions of bees into Nevada's desert. To many, it was the most absurd scene in modern agriculture. Social media erupted with clips of farmers releasing bees onto salty, barren ground, land that looked more like a wasteland than farmland. A case of animal cruelty, said agricultural experts. These farmers have lost their minds, neighbors claimed. Local news stations ran stories about what they called the doomed experiment. Everything seemed destined to fail spectacularly. But then came the twist. Just 1 month later, those very bees had become vital to the Gilcree orchard. They carried pollen from flower to flower, fertilizing trees and breathing new life into the desert. The same critics who once mocked the project were now scrambling to replicate it. What had looked like madness turned into a turning point. Skeptics realized too late they had underestimated a bold strategy that could reshape agriculture forever. The so-called agricultural disaster had transformed into a revolution. And in the face of a crisis threatening Nevada's way of life, these tiny insects proved they might just hold the key to the future of food. In the arid heart of Nevada, farming had always been a struggle. But by 2023, desperation had set in. Yields dropped every year, and the soil, increasingly alkaline from the mineral deposits of ancient lakes, seemed beyond repair. It was like fighting an invisible enemy that always won. Yet one crop still thrived against all odds: alfalfa. Its purple flowers hid a secret. With roots that reached deeper than any other plant, it tapped into hidden water sources. More importantly, its seeds were priceless, capable of holding moisture in the soil and securing future harvests. But there was a cruel twist. Without proper pollination, the fields bloomed beautifully, yet produced almost no seeds. Honeybees, the trusted allies of countless farmers, failed miserably. They avoided the flower's spring-loaded mechanism, too uncomfortable to trigger it. Thousands of dollars vanished each season. That's when researcher Dr. Clara Martinez stumbled upon something buried in history. While digging through 1970s agricultural studies, she found mention of a forgotten native species, the alkali bee. Solitary, living in underground saline burrows, these bees were unlike any other. And most astonishingly, they loved alfalfa. Each time they landed on a blossom, they triggered pollination perfectly. The problem? They had nearly gone extinct, wiped out by pesticides and habitat loss. Bringing them back seemed insane. After all, who in their right mind would salt their own land just to attract insects? Enter Farmer Bill Richardson. Willing to take the risk, he prepared 5 acres, poured in tons of salt, and built an expensive underground irrigation system. The sight was surreal. Trucks unloading millions of live bees onto a shimmering salt flat. The internet mocked him. Headlines screamed animal cruelty, and experts called it madness. But underground, a miracle was unfolding. The bees didn't die. They thrived. They dug perfect tunnels, built nurseries, and multiplied at astonishing speed. In weeks, Bill's land became a self-sustaining underground city of bees, protected by salt from pests and competitors. Then came the true test. Alfalfa fields nearby erupted with life. Alkali bees pollinated up to 300 flowers a day, nearly 4 times more than honeybees, and with almost 100% success. When harvest time came, the results shocked everyone. Up to 900 kilograms of seed per acre, triple the state average. Bill, once ridiculed, had turned his farm into an agricultural gold mine. Soon, Nevada wasn't a joke anymore. It was a global reference. The secret wasn't just dumping bees. It was precisely recreating the desert's unique conditions: salt, underground moisture, and centuries of genetic adaptation. Now pause for a second. If this revelation has already surprised you, hit that like button so more people can uncover this extraordinary story of science and nature. And the journey doesn't end here. Nevada's unlikely success didn't just save farms. It forced scientists to rethink everything they knew about pollination. What began as madness turned into a breakthrough that could reshape agriculture forever. Nevada's bees had essentially co-evolved with the state's native plants and its unique soil conditions. What seemed like a bizarre experiment turned into a revelation. The alkaline bee beds didn't just work, they actually boosted local biodiversity. They created pockets of moisture in the desert, provided nesting habitats for other soil insects, and helped sustain native desert plants. What began as a laughingstock became a triumph. Months later, the economic results silenced every critic. The final harvest numbers were so astonishing that denial was impossible. Nevada's struggling alfalfa seed industry had exploded into a $400 million annual business, powered by the efficiency of alkaline bees. Farms that once struggled were suddenly producing 3 to 4 times more seed per acre. The story of Bill Richardson says it all. Mocked for months, he ended up turning his experimental beds into a 1,500-acre operation, reporting over $4 million in annual profits. Nevada had gone from an agricultural joke to a pollination powerhouse. And it didn't stop there. Equipment manufacturers developed specialized tools for maintaining and expanding bee beds, fueling innovation across multiple industries. This so-called crazy idea didn't just work, it rewrote the rules. Nevada proved that sometimes the answer doesn't come from outside, but from making smart use of native species. And now I ask you, what do you think about using local, natural solutions to tackle modern agricultural problems? Have you ever seen an idea that looked insane at first, but turned out to be brilliant? Share your thoughts in the comments. And if this story already surprised you, just wait. In the next video, we'll uncover another unexpected innovation reshaping the future of agriculture worldwide.